So today we'll see how to control a stepper motor using our controller. So stepper motor, why you are using? In order to have some angle control over the motor. If you are using DC motor without any external step, without any external component, you cannot control the angle. You can only control the speed. So here, there you can control only the direction and the speed. You will not be able to control the angle of rotation of the normal DC motor. So for that you are using stepper motor, right? So in this case, let us take one step angle is 45 degree in this example, right? So if you want to have 360 degree, you will be having maximum 8 steps. Each step will take 45 degree. 8 steps are required. Right. But normally the stepper motor is available in different angles, say 1.8 degree, 0.72 degree, like that. Normally the stepper motor will be in 1.8 degrees. So when you are moving one step, it will move 1.8 degree. Right. So that is a precision or the resolution of the stepper motor normally you are having. Then there are two types of stepper motors: unipolar stepper motor and bipolar stepper motor. Right. So in the case of unipolar stepper motor, you can see that generally 6 wires will be there. 6 wires. Out of that, 4 will be the wires coming from 4 coils, and the other 2 will be 2 of the coils will be shorted together, and it will be taken as one wire, and the next 2 will be shorted together and it will be taken as another wire. So total 6 wires will be there generally in a unipolar stepper motor. So let us take this as a diagram. So how will you control the stepper motor? This both the common pin you will be connecting to VCC of the stepper motor, and each coil will be energized. When you are energizing this coil, how will you energize this coil? You will be applying ground here. Right. So when you are energizing this coil, motor will move one step. Then when you are energizing this coil, motor will move the next step. Right. Then when you are energizing this B coil, third step, A dash, fourth step. Right. Again, if you are continuing this process, it will keep on rotating in one direction. If you want to rotate in the other direction, instead of initiating the last, instead of energizing the first coil, you will be energizing the last coil. So it will move in the anti-clockwise direction. So in the unipolar stepper motor, always the direction of the current will be in one direction. Right. If you are rotating in a same direction, right. Always the current flow in the coil will be in one direction at a particular point of time. Right. Next one is bipolar stepper motor. So in the case of bipolar stepper motor, that common connection is not there. Right. So if you want to energize a coil, both the sides you need to give the supply, one VCC and ground. And if you want to reverse the direction of rotation, you need to reverse the polarity. That means in two direction you can apply the current. Right. That is why it is known as bipolar stepper motor. This is a normally seen stepper motor, permanent stepper motor. So here in the center of the shaft you will be having a permanent magnet. And how are you rotating it? Let us take you are having 4 coils, right? So if you want to rotate the coil from here to here, what you will make? You will make this B1 as north pole. So what will happen? This south pole will get attracted towards this. Right. Then you will make this as north pole. So from here to here it will move. Then you will make this as north pole. So that is how the motor is getting rotated in that particular step angle. In the case of permanent magnet stepper motor. Other type of stepper motors are there, but generally you will be using only permanent magnet stepper motors. And this is a connection for the stepper motor interface. So you will be using, for example, you are using P0.0 to P0.3. for connecting the stepper motor, right? And between the stepper motor and the ULN, between the stepper motor and the controller, you will be using an IC known as ULN2003. That is nothing but a stepper motor driver IC. Why you need to use this IC? So in order to handle the current, right? Because depending upon what type of stepper motor you are using, the coil current will be different, right? And the voltage also will be different. So let us take, generally we will be getting 5-volt stepper motor, right? And current will be say around 50 milliamps or whatever it is. So but your controller can supply only 3.3 because it is operating on 3.3, right? So what will happen? It will not be able to supply the current and voltage required. So for that you will be using this driver, and to this driver you will be applying the 5-volt and VCC, right? So that when the motor is rotating, input signal will be from the controller, but the coil current will be taken from the driver, from the supply given to the driver, not the VCC of the driver, from the supply of the motor which is connected to the ULN, right? And this ULN can withstand, I think, around 50-volt, 500 milliampere, I think so. 50-volt up to 500 milliamps, this can provide current. That is the use of ULN. So here it is very simple. How will you control the stepper motor? For controlling the stepper motor, I told already the common pin is connected to 5-volt, right? So what you need to do means, whenever you are giving a signal here, right? Say I am writing in this port, I am writing 1000. So what will happen? I am writing 1000. So the first pin will be connected to ground. So what will happen? The motor will rotate, will take one step. Then you will give 0100, right? So it will take the next step. Then you will give 0010. Then it will take the third step. Finally 0001. So it will take the fourth step. Even if you want to rotate in the other direction, opposite direction, what you will do? First you will give 0001, then 0010, right? Then 0100, then 100. That means the sequence you will be changing it just in the opposite way. First what I am doing, I am making P0.0123 as output. Then I am writing 1 to IO pin 0. 1 means 0001. Then I am left shifting 1 by 1. That means 2 I am writing to IO pin. That is 0010. Then 4 I am writing. That is 0100. Then 8 I am writing 1000. So the motor will rotate in one direction. How will you make it rotate in the other direction? The same sequence in the reverse order you need to give. Same sequence you can give it in the reverse order. How it will be? So initially I have given 1, 2, 4, 8. Then what I will give for reverse in the direction? I will give 8, 4, 2, 1. Right. Just reverse the value so that it will rotate in the other direction. Take that Proteus. You can take LPC2148. Can give the power supplies. Right. So next you can again take on component mode. click on pick from libraries, take ULN 2003. When you are typing ULN 2003, you'll be getting high voltage, high current Darlington pair transistor. Right. So you can add this. Finally, you need to add the stepper motor also. So you can use stepper. You will get 3 stepper motors. 2 stepper motor and 1 driver will be getting. So here I am taking animated unipolar stepper motor model. Don't take bipolar. Now we are using animated unipolar stepper motor model. So double click on this. So all the 3 are there. Right. So now you can give the connect the LPC, the ULN 2003. To which we need to connect this ULN according to the circuit P0.0 to 3. So I am taking this is a ULN, right? So I am connecting it. So P0.0 I am connecting to 1, this to 2, 3, 4. These are the inputs. And stepper motor you can take, can keep it here, right? So first, so here in these two terminals, these two are the center terminals. So first of all, you can short those 2 pins and connect it to VCC. So here I am taking VCC. VCC I am taking here. For that you can click on terminals mode, take power. So connecting it to this. Right. So I have connected 2 ends of the 2 set of coils. Then output pin 1 you can connect to first pin. This is the first pin of coil. This is the second pin. Third pin is here. So it is pin numbers are in the anti-clockwise direction. First pin, second pin, third pin, fourth pin. So 3C you can connect it to third pin. Fourth you can connect it to fourth pin. Right. Then here common also you need to connect it to 5 volt. Common you need to connect it to 5 volt. So now you can build the program. You can add the program to this. And you can build this. Finally you can add to the Proteus. Go to the project folder, take the hex file. Don't forget to give the 12 megahertz clock. Then you can run it. So it will be rotating in one direction. Now it is in the anti-clockwise direction. 4 steps it will be rotating. It will keep on rotating. And if you want to change the, if you want to rotate it in the other direction, you can copy and paste this also. After this, right? So I am writing 8, 4, 2, 1. Again give build. Stop the simulation and run again. So you can see that initial 4 steps it will go in the anti-clockwise direction. Then the next 4 steps it will go in the clockwise direction. So here you should keep in mind, this is the first coil, this is second, this is third, this is fourth in the anti-clockwise direction. If you are interchanging the connection, then it will not rotate properly. It will be going in both the direction. One direction. It will be oscillating between the. It will be changing the direction in between if we are changing the coil value.